Oh, thank you for the introduction, Barry. Yes, so I have just recently completed my master's thesis through Victoria University. I did this under the supervision of Professor Phill Lester, who can't be here. He's currently holidaying in Chile. I also completed my thesis with assistance from John Mackay at Denature, based in Gisborne. And my topic was looking at the distribution and population dynamics of all those words there on the screen. So what is a trypanosome? Well, it's a parasite which lives in the hind gut of honeybees, and it's been looked at pretty much all over the world. They were first identified in 1967 and have become more prevalent with all these colony losses that we're having. And in 2003, a study out of Belgium identified them as a contributing factor to overwintering colony losses. In 2005, a brand new trypanosome was identified called Lotmaria passum, and subsequently in that year, trypanosomes and Lotmaria passum was identified in New Zealand honeybees. So, an overview of my study. I started off with a snapshot study where I had 47 beekeepers send me samples from all across New Zealand. So that's from Kaitaia through to Gore. Of these 47 samples, 46 of them were positively tested as containing trypanosomes. All my testing was done with real-time PCR, and from those sequences, I was able to send those sequences away and identify them positively as Lotmaria passum. So 46 samples identified positively as Lotmaria passum. There was one sample that came back as not detected, and I'll talk about that one a little bit later. In addition to the snapshot study, I also looked at a year-long study where I had 15 colonies, again, all across New Zealand, however, only 3 in the South Island. And I looked at how changes occurred over time with these trypanosomes, but not only trypanosomes, I also had to add in there some Nosema species and deformed wing virus. Can't have a study without Nosema. So here is the results from my snapshot study. As you can see, Lotmaria passum there, pretty much everywhere in New Zealand. What you can't see is right there by Christchurch, there's actually one site that did not have Lotmaria passum present. And throughout the year-long study, it continued to not have any Lotmaria passum detected, so that's a site of interest for me. You'll also notice I looked at Nosema. Nosema apis was found all across New Zealand as well, as James just mentioned. Nosema ceranae, very prevalent in the North Island, not so much in the South Island there. And I can actually confirm that in my year-long study of Nosema ceranae, there was only 2 of 29 samples collected from the South Island that showed positive results for Nosema ceranae, and they were very low levels. I kind of skipped over the deformed wing virus there because, in all honesty, all the results that I gained from deformed wing virus were so variable, not only across sites, but also within sites. I couldn't really draw any real conclusions from that. A nice graph here for you. So this is an overview of my year-long study, which describes the prevalence of these pathogens over the year. They're sectioned into seasons there, and you can see Lotmaria passum, nice and high there, prevalent throughout the entire year, and at extremely high levels. And these levels are maintained throughout the year. They don't seem to have any variation over season. Nosema ceranae was the least prevalent pathogen in this study, and again, there was no real relevance of seasonality or time of year correlated in this study. So, wrapping it up, I wanted to identify what trypanosomes we had in New Zealand. We have Lotmaria passum. I did not detect any Crithidium maleficae. That's not to say that it's not here in New Zealand. It may be worth looking into different ways of detecting that. But Lotmaria passum, the name passum is actually a direct translation from everywhere. So very aptly named. It is found everywhere in New Zealand as well as around the world. Sequencing identified very little genetic variation in the samples that I studied, and in fact there was a single nucleotide polymorphism in one sample which I found in Gore, so there'll be some more testing on that to see if there is a genetic change here in New Zealand. But over the year there was no statistically significant changes. Sometimes you can look at samples and think you see a change, but statistics jumped in and told me that no, there's no statistical correlations there. What we did find was that there is a correlation between Nosema apis and Nosema ceranae. So when you find them, you will often find them together. And that potentially there is a correlation between Nosema apis and Lotmaria passum as well. And that's me.